Okay, welcome to Applied Science 1299. With a bit of luck, you've been able to download and install the software for this course without any problem. Here I want to show you a couple of things you can do to build your first project, some things to look for, and you can play around in, in MPLAB and XE8, and you don't need the computer chip. You can do lots of programming with what you have already. First thing I want to mention is the structure of the files we're going to use. Here, let me move this into place, you can see the setup that we want. Common is where we're going to keep files that we're going to be using over and over again. You might name various folders after whether you're in the lab or you're making up a homework project, something like that. If you're using your laptop, then you can of course have these files on your hard drive on your laptop. If you're in the lab, you should have these files on a memory stick. It's a little faster to have them in the on a hard drive. Okay, so let's create our first project. MPLAB opens up. This is an untitled workspace. This is simply asking what files are you using. This is output for various things. We don't care too much about that right now because what we're going to do excuse me, is use the project wizard to actually build the project every time we work. So the first thing that you must do is make sure this is the PIC 18F4525. That's the chip we work with. Right? Don't want anything else. You'll get all kinds of strange errors if you're using the wrong chip. The next thing is that if you've installed the XE8 tool suite correctly, it should show up like this, and then you say, yeah, let's collect that. Now what we're going to do is we're going to browse for a folder for a file that I've already corrected, and we need to give the file a name. I'm just going to call it first. Save. Okay. And then we add this file to my project. We can add other files to this project as well, and I'm going to do that to save some time later. I want this guy, this guy, this guy, this guy, and that guy added to my project. Save me a little time in this video later. Those are files that you'll typically be adding anyway. Okay, now we have the project set up. Let's go to my first program. Let's expand this so that you can see it. Okay, here is a typical C file. Every C project you create has to have one and only one file with one main function. Okay? So main is an integer and it returns a 0. The stuff that has to do with the computer chip is right here. This says include the XE8 compiler for this particular version of the chip we're using. Perfect. These things are called a standard configuration statements. We're going to be using this every project. So what we normally do is we just include all that text in a header file and simply call the file nits configuration bits. And if I minimize this and go over here, Here's configuration bits. It's the same code that we already had. Okay? Just saves time if we keep it as an other file. Okay. Now, this is our project. There's a couple of things that we should be careful about. Okay? In Edit, under Properties, see File Types, we should make sure the line numbers are visible and they get printed out when we want. So, these are the line numbers. Makes it easier to direct people. Say OK. Alright, now, it's not a very interesting program because it doesn't do anything. Okay? One of the simplest things we want to do is say, print something out. Something like this line right here. Now you may not have used printf, you might have used something like cout. It's similar but slightly older. There's some explanation of the printf in the manual, and we'll be talking about it a lot. Don't worry about it right now. Now printf is in a C directory called standard input. So we need to include that so that this will work. Now, this won't work for us because we're going to be using a computer chip, and the computer chip has a module that allows us to use printf, but we have to tell it about that. So there's two things we have to do. First of all, we're going to set the oscillator or chip frequency to 32 megahertz. The default is typically 1 megahertz, but our chip can go much faster, so we're going to use that. The second thing is to actually configure our chip to work well with printf. We're going to use something called a USART module. It takes a bit of work to figure out, so we've created a function to do most of that for you. The only thing you're going to need to know is that it works at 9600 bits per second. The UL just says it's unsigned long. And we're running our chip at 32 megahertz. Now these functions are already in common, but we have to tell the system that we have it. So os.h, that's for the set the oscillator to 32 megahertz. And then this configure USART module function. Okay, so everything about our computer chip is part of this function right here. Printf is in standard I/O. This is the lines that we want in every code, so we've made it in a header. This function, set os 32 megahertz, is prototyped in here, and the configure USART is prototyped right here. So I'm going to go ahead and build it and see if I have any typos. Yay, build successful. That's telling me that I don't have any problems here. So that's perfect. Okay, I'm going to close that down and come back to here. Now, I'd like to see if it works. You don't have the computer chip to actually see that it works, but we can use the MPLAB simulator to see if it works. Okay. We also have to tell it to create a little window for us. First of all, we're chip is now running at 32 megahertz, and we want a little window to see what happens when we print this out. So I'm going to rebuild just to make sure. Now up here, this is the window that any output from that program will go to. I want to see what that output is like. I just press this run button. Hey, oh, hold on, that's interesting. It's not printing it just once, it's printing it, it printed it many times. Well, that's not a bug or a problem, that's actually a feature of this particular chip. When you have something like a PIC, if it loses power, you want it to start again. So this program, when it finishes, restarts. And to keep it from doing that, we're always going to want to line something like this while one. This return 0 is now unreachable code, so we just get rid of that. Right, so I'm going to compile this. I'm going to go to the UART window, and I'm going to clear the page. And now, when I run, I only get one of these. You can see the program is still kind of running down here, the simulation anyway, but it only prints out hello world once. Okay, so that's it. Here's the typical first program that you would use with the typical functions that we've given you. Okay. We're going to use printf for printing. If you want to use printf, this has the functions we need to make that happen. Okay. The 32 hertz refers to the operating speed of the computer chip we're using. To make it operate at 32 megahertz, we need this function right here. If I want, I can set this to 1 megahertz, and it should work fine for me. Okay, no problems here. Come here and run it one more time. But it worked great. Thank you.